Hi everyone, Unit 4, Day 4. I'm just going to focus in here. We're going to look at two ideas today. Number one idea is the inverse of a function. And to find the inverse of a function, all you do is you swap the x and y values. You switch the x and y places. So this number one is just for number one, our large first idea. To find the inverse of a function, you switch the x and y values. If the original function is f of x, it's written as f with this little -1, which would be read f inverse of x. This is the notation. Recognize that this is not an exponent. You can't go to your calculator and type in a little power of -1. It's just how they write something if it's an inverse. They put a little -1 up there to indicate that. All right, our first example, I just gave you some ordered pairs in function a. It's 0, -1, 1, 0, 2, 1. If they ask you to find A inverse or the inverse of A, all you do is take these ordered pairs and swap their spots. So it's -1, 0, 0, 1, 1, 2. Just take x and y and switch their places, and that is the inverse. They can ask you about domain and range and is it a function, all those same questions about the original or now about the inverse of the original. So in this example, the original was a function. The inverse is also a function. The original was 1 to 1, the inverse is now 1 to 1, and all those kinds of things. One more example here. Here's function g. G was -2, 4, 1, 1, and 3, 4. To find g inverse, you just switch their places. So 4, -2, 1, 1, of course, is still 1, 1, and then 4, 3. And you'll notice that here in function g, the original was a function because 2, 1, and 3 are all different. But it wasn't a 1-to-1 function because the 4 is repeated, right? So I would have said no to the 1-to-1 question. It is a function, but it's not 1-to-1. And then when I reverse all the x's and y's, in the original the y's were repeating, but when I reverse it, now those y's are x's. So what does that mean about g inverse? G inverse will not be a function. No, not a function. Because all the things that were y's are now x's. So the basic idea is if the original function is 1-to-1, meaning all the y's are different, when you write the inverse will also be a function. But if the original thing is not 1-to-1, then this new inverse function will not be a function. So I just wrote that here. If my original function is not 1-to-1, the inverse will not be a function because the y's become the x's when I reverse their places. All right, so that's idea number 1 with coordinates. Oops, sorry. Idea number 2 is, to continue on with this idea of inverse of a function, they can also ask you to find the inverse of a function when it's an equation, when they give you an equation of a line or a parabola or a cubic function or something. So our steps to do that, here are your steps. To find the inverse of a given function when it's an equation, you're going to replace the f of x with y, because y and f of x are the same thing. You're going to switch the x and the y places, and then you're going to solve it out for y. You should have 4. Solve the equation for y. Get y by itself. And then you replace the y with this f inverse of x notation. Okay, so let me show you an example or two of this. Let's start with something that's maybe a linear function. This is usually my kind of background sheet, but if we do f of x equals like 2x plus 3, let's say, and they ask you to find the inverse. All right, step 1, you're going to replace f of x just with a y. Step 2, you're going to switch the x and the y places. So it'll be x equals 2y plus 3. And now the last step, just solve for this y, get y by itself. So we're going to subtract the 3 over. And then to get the y alone, we're going to divide everything by 2. So my final answer here looks like y will equal like 1/2 x minus 3 over 2. But again, we never had a y to begin with. We had this f of x notation, the function notation, so we should just replace this y when we're all finished with the f inverse notation. I want you to think for a quick minute about what this graph would look like. If I graphed this on my graphing calculator or by hand, it would have a y-intercept of 3 and a slope of 2, right? So maybe something like that. And then if I graphed this one, it would have a y-intercept of -1.5 and a slope of 0.5. So something more like this. Can you kind of see what these lines look like, even though, we've just made a very quick sketch? They are a reflection in this y equals x line. Now reflection you did last year in geometry. When something reflected over the y equals x line, the y equals x is just this diagonal. The rule was take the x and the y and switch their places. This was the rule, if you remember learning all those rules about reflecting the origin, reflecting the y-axis. We don't have to remember all of those from geometry. This is the one that you need to know. And the rule for reflecting the y equals x was switch the x and y places, and that's exactly what we do when we find the inverse of a function. All right, so one more fast example here. Let's do a different letter. Let's do g of x equals the square root of, let's say, x plus 1 or something. Oh, shoot. No, actually, let's do something a little different. Let's do g of x. Okay, so sorry, get rid of that. Let's make it a parabola, x squared plus 1. And they ask you to find the inverse. You're going to replace the g of x with a y. You're going to switch the x and the y places. And then I'm going to solve it for y. I'm going to get the y by itself, so I'm going to subtract the 1 over. And then I'm going to square root both of these because I want by itself. So this will give me a single y. Over here I'll get this. Remember that in front of it we need that good old little plus minus because we learned that in the last unit. We have to do that when we square root. And then just one more step. Instead of y, we're going to replace that with g inverse. So if this is my original equation, this new one right here is my inverse. Now you can graph them both on a graphing calculator and get a very nice visual, but I'm just going to make you an easy sketch. This is a parabola with a y-intercept of 1, right? So something like that. And then if I went to graph this one, I would need to graph it in 2 parts, one with the plus and one with the minus. I think it's going to look something like that. And then the minus gives you that. All right, it doesn't look great because I've just drawn it real quick, but do you recognize that that does look like a reflection in this diagonal? If I could fold that parabola over, this line would go here, this would go here. And so you get that visual. We've only had parabolas before today that were smiles and frowns, and now this is how you get a parabola that goes sideways by doing the inverse function, which is a reflection over this diagonal. Okay, so that was idea number 1. Finding an inverse is just switching the x and the y. Sometimes it's very simple like ordered pairs, sometimes it takes a little bit more work with equations, but you should always get something that's symmetrical to the diagonal. All right, idea number 2, big idea number 2 for today is variation, types of variation, and there are 2 types, direct and inverse or indirect. So this is big idea number 2. When they tell you that things vary directly, you are going to make a proportion and solve it. So if they say x varies directly as y, x is 2 when y is 6, find x when y is this. This is like what you did with similar shapes. We are going to make a proportion. So direct means divide the 2 things, whatever the 2 letters are, the x and the y or the a and the b or whatever. Indirect, or inverse variation, we're going to multiply. So this one is multiplication, this one is division, and you kind of set up your own little thing like this, and then we just fill it in and solve. Here we're going to set up our own thing and fill it in and solve. But you just need to know to do what thing for what thing. So if it says, you know, y varies directly as x. Here's my example number 1. If y is 35 when x is negative 5, find y when x is negative 20. So when you read this, you see y varies directly as x. You're going to say directly, oh, that's division. Directly means divide. So I'm going to do y divided by x equals y divided by x. I'm going to make a proportion, and then I'm just going to fill it in. So 35 on top, negative 5 on the bottom, equals y over negative 20. So I just put y over x equals y over x, and then I'm just going to cross multiply. I'll get negative 5y on one side, negative 700, y is 140. Let's show one inverse example as well, and then we'll be finished for today. All right, last little blurb. We'll need to clarify a few little odds and ends here when you come to class, but you'll have them, you know, the basic idea. You'll see this variation quite a bit in science class as well. This example says an electrical circuit, the current varies inversely as the resistance. But let's just make it a little simpler and say C, varies. C varies inversely as R. If C equals 40 when R equals 12, find C when R equals 20. Sorry. All right, so when you read that problem, the idea is I have to set up either a proportion or a multiply. So C varies inversely or indirectly as R. This one means multiplication. So I'm going to go C times R equals C times R and set up a little thing just with my letters. And then we'll plug in 40 for the first C, 12 for the first R. So it's 40 times 12. And on the other side it says find C. You could put an X in or you can leave it a C when this is 20. And then we'll just solve that out. So I get 20C on this side. Looks like I get 480 on that side, and then divide through by 20. C equals 224, right? Sorry. And that's the example. So if it's direct, you make a division problem. If it's indirect or inverse, you make multiplication. And just put 2 letters, 2 letters. There's one other thing they can do, which is sometimes they'll give you a word problem and you need to figure out if it's direct or inverse. But for tonight, this will give you the basics, and then we can cover that when you come to class tomorrow. All right, last little thing I have for you is 3 examples, and if you would like to try them on your own, as always, it's a good idea. Whoops, let's go the other way. So what you can do here is pause the video, work them out, and then when you hit play again, I'll show the answers. So we've got one with inverse variation, one with direct variation, one where they're asking you to find the inverse of a function. And that's it for today. So thanks a lot. Have a great night, and we'll see you tomorrow, everyone.